Galaxies. We live in one called the Milky Way, but there's galaxies all across the universe. In fact, there's estimated to be about 2 trillion galaxies like this one, these spiral arms of billions and billions of stars. Now, there's one galaxy that's making some headlines, and it's not ours. It's the one that's out a little far away called M101, also known as the Pinwheel Galaxy. And all eyes are peeled on this amazing galaxy because something new has exploded. A supernova explosion that's almost doubled the brightness of the entire galaxy. And I don't know about you, but I got supernova fever. It's hot. Welcome to our show, All Night with Dean Regas, and I'd love to have you stay up all night to ponder the vastness of the universe, learn about new discoveries in space, new space missions, and things like this. Sometimes, very rarely, we get things like this happening, a supernova explosion. I want a supernova in our galaxy, but for right now, we're dealing with supernovas in this other galaxy called M101. Now, what a supernova is it is a gigantic, massive star. At the end of its life, it just explodes. In an instant, the one single star can have the similar brightness of a galaxy of billions of stars. So when a supernova happens in a galaxy like this one, this is galaxy named M101, also known as the Pinwheel Galaxy. Well, this is what it normally looks like. And then when a star explodes, it releases so much energy, it is ridiculous. And so amateur astronomers were treated with an amazing sight. They were looking at M101 and taking pictures of it as normal. This is a couple pictures by Paul Jacklin, an amateur astronomer. And the picture on the left is before the explosion. Picture on the right is the explosion. And you can see how bright that thing is. So that is one solitary star in a pinwheel galaxy of billions of stars. Now, this is not really close to us. This is about 21 million light years away, and 1 light year is about 6 trillion miles. So I'll do the math later, but it's far. Now, so this is not something you can see with the naked eye. You need special equipment. Even through giant telescopes, this is hard to picture. But if this supernova happened in our galaxy, it would be incredibly bright. Now, when you see a supernova, you often think, at least some people, try to think of, all right, well, is our sun going to explode someday? Our sun's a star. Surely it would explode. Well, not exactly. Now, the stars that make supernovas are exceptional. They are behemoths. They are obnoxiously large. And our sun is kind of mid-size. So this is kind of the way that stars live and die. They're all born from this cloud of gas and dust called a nebula. And an average star like our sun follows the path at the top where it just gets a little bit bigger. It has a planetary nebula, which isn't really explosion, but we'll talk about that in another show. And then at the end, it comes to be a white dwarf star. But the star we're looking at in this Pinwheel Galaxy is a supermassive star. So then we follow the bottom track. And that's what it did. It started off as a super big blue star, then turns into a red supergiant star, then releases all of this energy all at once into a bang. And then what comes out the other side? Well, depends on the size, but black hole is a possibility. But you get something like this. This is a supernova that happened in our galaxy. This is called the Crab Nebula, and this happened a long time ago. In the year 1054 was when this supernova happened. And so this is a picture taken by the Hubble Space Telescope of this in modern days. And so it is still lighting up the sky, but not as bright as it was 1,000 years ago. So this is one little problem, is that when you hear about supernovas and you see these great, glorious pictures, you think you're going to be able to go outside and find this yourself. In fact, I've read some, internet report stories of from real reporters that can write on the internet that you could see this with a small telescope. To these internet writers, I just have to say, please stop saying that. It's not true. You can't see this with a small telescope. just stop it. Just don't do that anymore, because this is what it would look like with your eye through a gigantic, massive professional telescope at the best possible conditions. We can't even see it like this at the observatory where I work. The only way you can really see this is if you have long exposure photographs. That's the thing, when you see these great pictures of these galaxies, they're usually like minutes and minutes long of exposures. Some of them are even hour-long exposures, and so the eye can't pick this up. So I have to be Mr. Astronomer buzzkill. You're not going to see this yourself, I'm sorry to say, but we've got some amazing pictures of it. And I'm holding out hope. We got to have one in our galaxy, and then we can see it. Then we're talking. So having a supernova in our own galaxy, man, that would be sweet. And the reason why that would be sweet is because we have these reports from old supernovas that happen. And take this one. This is a supernova that happened in the year 1006. And this is the remnants. This is a modern picture of this. And the reports on supernovas like this are that suddenly this star erupts, a star that people had never seen before in constellations just erupt to brightness, and that in some cases are so bright that they can be visible in the daytime. So you're outside on a sunny day, you got the sun there, and you got another pinpoint-like sun out there. That's how bright a supernova could appear. And so this is the one from 1006. This is another one from 1572, at least the remnants of it. This one was viewed during the Renaissance time, and some of the famous astronomers from Renaissance got to see this. But the last one of any decent brightness, of a decent size, was this one, 1604. We have not had a supernova explosion of any size and brightness since 1604. Man, this is like a drought. What's happening here? I mean, we need one. And so when you get these things happening, first off, I got to tell you, when we do have a supernova in our galaxy, we are safe. We are very, very far away from the stars. And so any of these blasts and eruptions won't be able to travel to us, at least those stars that are these massive ones that we're looking at. And so that's what makes them so great. You can just like kick back and like, yeah, all right, check out that supernova, and you're perfectly safe. It's pretty cool. So now some people might be like, well, Dean, yeah, like I heard about this one, supernova 1987A. And yeah, that one was pretty good, but this one was not in our galaxy. It was in a nearby galaxy, and it was cool, even though I don't really remember it. I don't know what I was doing in 1987, but I wasn't looking at this, that's for sure. It wasn't good enough for anybody, the amateur or just even the public to get excited about. Astronomers got really excited about it. But this was still not in the same category as like the big one in 1604. So that means nobody has photographed a supernova in our galaxy of any brightness. And all we have to go on are the reports of the people that observed it. Some of them reporting them with shock, dismay, fear, superstition, all sorts of stuff. For me, I'm just gonna love every minute of it. So whenever anybody hears that I'm an astronomer, they naturally have space questions. It's like they're like compelled to ask me all the mysteries of the universe. And so I started this segment called Hey Dean, where you can ask me any kind of space question as long as you start it with the preface, Hey Dean. And so today, we actually have a real person that had a real question, a real Hey Dean question. It comes from Chuck in Hyde Park, who says, Hey Dean, when's the sun gonna die already? Now, I took that as a lot of different ways. Mostly I thought Chuck probably was thinking a little too hard about this, and maybe in some cases when people think about the stuff exploding, they actually might be like looking forward to it, but that's their own twisted problems. But for us, we're going to talk about this as a scientist and specifically what is going to happen when the sun does die, because I'm sorry to tell everybody, the sun is going to die. I have to break it to you. Now, what's going to happen to our sun is, well, not that. That's the wrong picture. No, this is a picture of where stars come from. So our sun came from something like this. This is called a nebula. In this case, it's called the Lagoon Nebula, one of the biggest star factories in our nearby space. And so lots of stars can come from this. So our sun came from a big nebula, something like that. condensed into the star that we know and love, and then we'll eventually run out of fuel. So that's what we're seeing. When our sun lights up, that is it using its fuel to light up the Earth and heat and everything like that. So it's eventually going to run out. And when it runs out, it will swell up into a bigger size, swallow up Mercury, swallow up Venus, and possibly swallow up the Earth. Now that's bad news. And the problem with this is, yeah, we're in big trouble when this happens, and there's probably not a lot we can do about it. The good news is we know about when this is going to happen. We can, astronomers can make a little estimate. If the sun continues to use its fuel at the current rate and nothing strange or unusual happens, we will see the sun change and form into a new thing and destroy the Earth in about 4 to 5 billion years. So we got a little time. That means you still got to go to work and stuff. Because, yeah, this is a long time in the future. Our sun is very stable. And for the length of many, many lifetimes, sun is going to be just fine as we go on. But if you're really morbid and all, you want to see what our sun's going to do, this is what will happen. Something similar to this. This is called the Helix Nebula. So this is a sun-like star that at the end of its life can't hold itself together, swells out, and the shells of gas go out. So it's basically the shells of the star just going out. Not quite like an explosion, more like it just can't hold itself together. But if you look at the very center of that, oh wait, I have a close-up picture. These, you can actually see some of the close-up star bits flying through space. This is such a cool picture from the Hubble Space Telescope of these star bits. But we'll go back to this one because at the very center of this nebula is a little tiny dot. That little dot is the star that did this. So the sun will continue on. Even after it wipes out and obliterates all the planets, it'll continue on as a little white dwarf star and could live up to another 1 trillion years. So I don't know if that makes you feel any better. At least the sun won't completely die. You know, we're going to be in big trouble. But again, remember, 4 to 5 billion years from now, not like tomorrow. Well, that's it for this week's episode of All Night with Dean Regas. Thanks so much for staying up a little later to talk about supernovas and that supernova in the Pinwheel Galaxy M101. We'll be keeping tabs on it, see if anything happens. And hopefully we'll have a supernova in our neck of the woods too, because that would be pretty awesome. So if you like these programs, be sure to hit like, subscribe, comment, and share with lots of people. We'd love to have everybody find this. And if you have a burning space question that you want to ask me, you can type in the comments, start it with "Hey Dean," and we may use your question in a future show. So until next time, everybody, well, thanks for staying up all night with me.